All right, so let's go over 8.4 here. All right, number one, for each scenario, determine if the conditions for constructing 90% confidence interval for the population P are satisfied. If the conditions are met, clearly define the parameter and state the confidence level. If the conditions are not met, explain why not. A commercial baker selects a random sample of 15 muffins. Well, right there, we're done. We got random sample, going to assume 15 is less than 10% of all muffins. From the hundreds of muffins, we got that. But we need n times p to be greater than, in this case, n times p hat. To be greater than or equal to 10, and n times 1 minus p hat to be greater than or equal to 10. Well, that can't possibly happen with 15. Okay, so we'd have to have at least 20, and that's if it's a 50-50. Do we have anything else here? The muffins, like I said, 2. So we have 2 successes. Is that how you spell it? Successes, or just one S there? And 13 failures. But 2 is less than 10, so the large counts condition is not met. Okay, senior class page has 530 students, 40 randomly selected, and 40 is less than 10% of 530, so random is met. So now let's check 65% of the 40, 0.65 times 40 is a number, in fact, and that number maybe is 26. I think I did this earlier. 0.65 times 40, 26. So we have 26 is greater than or equal to 10, and we can do 40 minus 26 is 14, which is also greater than or equal to 10. So all of that is good. We got all conditions met. So the parameter is the true proportion of students at Page's school, of seniors at Page's, I don't know why that's happening, school, who plan to attend a four-year university, who planned to attend a four-year university. And well, we need the confidence level. That's a silly thing to kind of ask. The confidence level, 90%. Oops, wow, that was terrible. 90%. I drew a 9 and a percent sign the same way. All right, we're on the next one. In a national survey, Grand Canyon University collected 1,000 responses, collected responses from 1,000 randomly selected college students from various U.S. secondary institutions. They surveyed that, found that 63.8% of respondents preferred writing over typing class notes. Suppose you want to construct a 95% confidence interval to estimate the true portion of all U.S. college students who prefer writing over typing class notes. Define the parameter of interest and choose the appropriate Choose the appropriate inference procedure. So, parameter of interest is the true proportion of all college students who prefer writing over typing. The inference we're going to do procedure is a 1 prop z interval for p. So we need 3 conditions. Random should say randomly selected. So that is stated. 10% condition, 1,000 is less than 10% of all college, it's weird, students. And we need the normal condition. Well, what was our thing here? 63.8. So 0.638 times 1,000, 638. So 1 minus 0.638 times 1,000 is what, 362? And so both greater than or equal to 10. So we're good there. Condition met, perform the calculations to give the interval. You can do this in your calculator. It's not asking you to do the construct thing. Let me see if I can fit the calculator on your screen here. I have to shrink it down a little bit. Okay, so I'd be down here. So we're gonna do menu, statistics, confidence intervals, one prop Z interval. Number of successes was 638 out of 1,000. Say 95%. Yes. So from 0.61 to 0.67, looks about right. Now they're going to probably want you to do the whole, I don't know why that just popped up, sorry, go back. You'd want the, plug the numbers in, right? Point estimate plus or minus margin of error, 0.638 plus or minus, and we're going to use 1.96 because of our 95%, 0.638, and what, 0.362 over 1,000, and that will get us 0.61, 0.67. Interpret the interval in context. We are 95% confident that the interval from 0.61 to 0.67 captures the true proportion of all college students prefer writing over typing notes. Don't have room to write it there. Okay, 3, a polling organization wants to estimate the proportion of likely voters who plan to vote for a certain candidate in an upcoming election. They will select a random sample of likely voters to construct a 95% confidence. The polling organization wants to have a margin of error no less than 0.15. So using the conservative estimate for p hat has a likelihood of voters. So we're going to do, this is our numsolve thing. You're going to do 0.015 equals, we got 95%, so we're using 1.96 again. We don't know what p hat is, we're going to use 0.5, and we're going to solve for n. We put all that into numsolve, see if we can bring up the calculator again. So menu, algebra, numerical solve, and we're going to do 0.015 equals 1.96, control, get the square root, then hit control divide, and we have 0.5 times 0.5 over n, get out of there, comma n. So 4268.44, we always round up, so 4269. So we get, n would need to be 4269. Again, sorry about that. Preliminary poll by a different organization found that 0.62 of respondents plan to vote for this candidate. We're using 0.62 as an estimate. for p-hat increase or decrease sample size compared to part A. When you use 0.5, that's as wide as it can get. So going to 0.62, it will decrease because that number on top is going to get smaller. 0.62, if you want to know it, 0.5 times 0.5 equals 0.25. Well, then we'd have 0.62 instead times 0.38, and that will come out to a number, in fact, and that number is 0.24, or ish, by the way, which is smaller, which would make our margin of error smaller. So now they want us to calculate it for this one and see if we came out true. So we're going to solve this again, this whole thing numsolve-wise, but we're going to do it with 0.62 instead. So we can just go up twice, copy and paste it, then we're going to change this to 0.62, this to 0.38, which if you wanted to do 1 minus 0.62, you can, and we get 4023. So we get 4023, and yes, prediction was correct. Okay. Moving on. By the way, if I'm using the PDF of these, sometimes I eliminate them from the Schoology one, and I don't remember. So if I go over a question here that's not on there, well, that's just bonus. Okay, manufacturing company specializes in steel-based technology, routinely samples their products for quality. Well, a particular type of small steel plate used in electric motors called lamella requires thickness of 0.355. Random sample of 800, 98.3 met the thickness required of less than 0.35. So over 300,000 are made every day. Construct a 90% confidence interval for the true proportion. So what we're going to use, we have to do the whole 4 C's. I don't know if I can fit it all on here, but we're going to try. Check. I'm sorry, no. I'm already stepping ahead. So we're going to start, choose. We'll do 1 sample, 1 prop, Z interval. And for P equals this, the true proportion of all lamellas that meet the thickness requirement. You cannot draw an arrow to the words. You're going to have to actually write them. Sorry. Check. Is it random? That should be stated. Random sample, stated. There's over 3, so 800 is less than 10% of 300,000. And 800 times what? 98.3 is a number. 800 times 0.983, sorry. 0.983 is 786, so that should be 0.983. 786.4, so that means what? Those are our successes, and then we have 13.6 failures, so both are greater than or equal to 10. So we're okay with normal. You need to write it out a little better than I do. Now, when you put this in your calculator, you're going to have to kind of round there. And it really doesn't matter the way you round either way. So let's just go ahead and run it here. So menu, statistics, confidence intervals. We're going to do a 2-prop Z interval. I'm sorry, no, this is a 1-prop. My bad. I'm getting ahead of myself. Statistics, confidence intervals, 1-prop Z interval. Number of successes, what we say was 786. So let's just call it 786. That's fine. One number either way is not going to change much. And they wanted a 90%, so 0.90. So we get 97 to 99%, okay? There's our margin of error, there's our point estimate, blah, 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 blah. We're all good. Okay, so then we do calculate. And we're going to do point estimate plus or minus margin of error. So we're going to do point estimate is 0.983 plus or minus the square root of 0.983 times what? 0.01. So we can just do 1 minus 0.983 over 800. And we should get 0.97 to 0.99. We have to draw a conclusion. We are 90% confident that the interval from 0.97 to 0.99 captures the true proportion of all lamellas that meet the thickness requirement. In order to show an improvement in quality from the previous year, the company must demonstrate that at least 98% of the lamellas meet the thickness requirement. Is there convincing statistical evidence that this goal has been achieved? Justify your answer. No. 0.98 is in the interval. And numbers, this is actually the more important part, numbers less than 90.98. It is plausible, because all the values in that interval are plausible, that it is less. Okay, number 5. The American Time Use Survey, conducted by the U.S. Bureau of Labor Statistics, collected data from 8,100 randomly selected adults, found that 85% of women, and 70% of men spend time every day on household activities such as cleaning, food preparation, or lawn care. Suppose you wanted to construct a confidence interval for men and women separately. Explain why this is not possible. These are not. We don't know out of the 8,100 what proportion were men and women. These are not from independent samples, so we can't calculate the errors correctly. They're not from independent samples, is what it boils down to. Part B, do you think a 95% confident proportion of all men who spent time every day on household activities would be wider or narrower than 90% of proportion of all adults? And give a reason for your answer. Well, simply because if you're limiting yourself to men, you'd have a smaller sample size. There, sorry. Smaller sample size. Would give you a wider interval. Just by limiting yourself to just men, you'd have a smaller sample size. You'd cut some number out of that 8,100, and so your sample size would be a lot smaller. So you'd have a wider interval. Okay, let me check something real quick. Okay, number 6, random sample of 50 customers at a local diner were asked to choose their favorite pie from 4 pies offered on the menu. Response shown on the table below. Based on the sample, a 95% confidence interval, the true portion of all diners, customers who prefer fruit pie, so that would be these and these. So 35 out of 50, so that's 0.7. So there's our point estimate. So that one's gone, that one's gone. We're down to those. So we're going to do 0.70. And actually, we can just do this probably pretty quickly in the calculator. Menu, we're doing a 95% confidence interval. So, because this will tell us our margin of error. We're doing number of successes, 35 out of 50. 95%. So we're looking for this margin of error, 1.2702. And that is this one right here. Oops, sorry. 1.2702. So you can even get that straight from the calculator, nice and easy. Okay, let's move on. Number 7, hospital wants to estimate the proportion of emergency room patients who are seen by a doctor within 1 hour of arrival. They plan to survey a random sample of patients and then construct a 90% confidence interval, which is the smallest sample size. They'll guarantee a margin of error of 5 points or less. So this is that same thing. You're going to set up 90%, I think is it 1.645? So we'd want 0.05 to equal 1.645. We're not using 1.96 because they want 90%. And we don't know p hat, so we're going to use 0.5 again, times 0.5 over n. We're going to solve that, use numSolve. All right. So we got menu, statistics. Oh, no, we're doing algebra, numerical solve. Oops, let me get on the right thing here. Menu, algebra, numerical solve. And so we do 0.05 equals 1.645. And we do square root. If you know it off the top, you can do 0.25 on the top, because that is what 0.5 times 0.5 is, n, comma, n. So it says at least 271. Let's see what our choices are. So 275. Oftentimes on these, they do that. They give you, they ask you not the exact number, but which of these would do it, and would have to go up instead of down. Okay, there you go.